Hi everyone, I'm Stephen Morgan and I'm excited to speak to you today at the Scholarship of Technology Enhanced Learning Symposium. I'd like to acknowledge Indigenous people's continuing connection to land and water. I'm on Wurundjeri country at the moment, and so is the University of Melbourne where I work, and Melbourne Bioinformatics. What I'll be talking to you about today is how we use CloudStor SWAN in the teaching of a master's level subject. So what we do at Melbourne Bioinformatics is help researchers and students with their bioinformatics needs. If you haven't heard of bioinformatics, it sits at that intersection of biology, computer science, and mathematics. It's a really exciting field that integrates well with a lot of other disciplines, especially in this time of global pandemics. And more about the teaching specifically, we look after the Master of Science Bioinformatics program, which involves coordinating a number of subjects, and that's one of my roles. We also consult with other teaching staff. And on that note, if you're interested in adding some bioinformatics flavor to your teaching, then please get in touch. And part of my job is that I'm lucky enough to be a subject coordinator for a master's level subject at the University of Melbourne called computational genomics. So I'll be addressing the following set of pretty basic questions. First, what is the subject and why did we need something like CloudStor SWAN? We'll also talk about exactly how we use SWAN and how that may be useful for others, both from a teaching and learning perspective. So as a quick primer to the subject, it's called computational genomics. We had 86 very bright students from a range of master's programs. We were teaching online like a lot of the education sector, and we ran a standard 12-week semester complete with assignments and an exam. So this is a highly condensed version of the intended learning outcomes of the subject, and it just serves to say that this subject is about coding, it's about programming, and we don't just talk about programming, we want our students to actually practice these skills that we think are so important in this field. So what is CloudStor SWAN? Well, in short, it's a web service run by an organization called AARNet, where researchers can run their analyses online. And it uses Jupyter Hub. So all you really need is a web browser and you are ready to go. It's that simple, nice and accessible. So why use SWAN? Well, on a very practical level, it ensures that no matter whether students use a Mac or a PC or they're Linux users, and no matter what they've got installed on that machine, it will just work. It means we're using the same instructions for everyone, and it also simplifies our troubleshooting. In terms of fairness, every student's environment is exactly the same. We avoid that situation where a student's code doesn't work because it relies on something that they've got on their unique personal setup. And another practicality is that when we're marking assignments, we can't have students' code running forever. So we do use rough runtime guides. And what we're really doing in this subject is aiming to train the next generation of researchers. So part of our course is about useful skills that can facilitate research, and that includes SWAN itself. And critically, once the semester's over and the students walk into the sunset with their great results, all of that work is still there and they can refer to it. So how did we actually use SWAN? Well, the first step is the setup. It's incredibly easy. It's really simple to get an account. You pick your institution from a long list of Australian, New Zealand research bodies. Use your institutional login, so there's no new password to set up. So the key thing is that the interface is really playing a supporting role here. We had a workshop every week, and that's set up in documents called Jupyter Notebooks, one for each workshop. And we use them because it allows us to have everything in the one place. And it's really simple for the students to learn. So here's what one of our workshop tasks actually looks like. You can see the instructions. There's some code there with a space for the students to write their own code in. And underneath, the students can test their own code to figure out if their solution is valid, or maybe try some new test cases that they might come up with themselves. So separate from Jupyter Notebooks, SWAN also allowed us to teach command line skills. And I found that we got comments from past students saying that they never really had any formal training on the Unix command line, and that was quite important for a future job or a research project. And again, SWAN allows us to do that with that consistent interface that is going to look the same for every student and for the teachers for that matter. We use the same Jupyter Notebook format for assignments, and we do that very deliberately so the students can focus on the task, not the interface. And we were able to ask both code and written questions side by side in the same document. The code questions can be automatically marked and the responses can be checked for plagiarism with Turnitin. And again, here's what an assignment question looked like. It's very similar to a workshop exercise. You can see 2.4, that's a code question, followed up by 2.5 is an explain question that is related to the code that they just wrote. And it allows us to have assignments set on certain topics rather than segregated coding assignments and then later separately a written assignment. We also chose to incorporate coding into our online exam for the first time. Previously, we had students in exam halls writing with pens like we're all probably used to, but that really didn't suit subjects with strong coding components like this one. And I'm pleased to say it went off without a hitch. So to wrap up, from a student perspective, using SWAN to teach coding skills is almost frictionless. University students have enough to worry about in 2022 without having to deal with confusing new interfaces that don't necessarily work across borders. And from a teaching perspective, it's easier to design effective lessons. It's easier to troubleshoot things if they do go wrong. It's nice and easy to share and collaborate with others too, which has been really useful, I found. And I'm pleased to say that the platform that we've used here has been used as a model at other Australian universities. So I'm really pleased that I can pass some of this on to you. And of course, a big thank you to the teaching team, to my Melbourne Bioinformatics colleagues, to the collaborators behind the scenes at AARNet, to our wonderful students, and of course to you all for watching. Thank you very much.